In this video, I want to do the formal proof for problem 71. The formal proof is based on the scratch work that we went over in the previous video. So to get started, we're going to let the pKs be a sequence that is known to converge to x, and the qk's are going to be a sequence that is known to converge to 0. And our goal is to show that the sequence of pk times qk's also converges to 0. So what that means is we have to show that if S is any open interval containing 0, so any open interval with 0 inside of S, then we can trap an entail in the open interval S. Let's just draw that as an idea. So here is 0, here is an open interval S, and I need to trap the entail inside this open interval. Now, in order to do that, what I'm going to do is I'm first of all going to pick a more controlled number. I am going to choose delta bigger than 0 such that the delta ball about 0 is a subset of the open interval S. So let me put that in a different color. So this would be delta and this would be minus delta, and this white set is my delta ball. And our goal is going to be that we will trap an entail for the product sequence inside this delta ball. Because if I do that, then it will also obviously be inside the open interval. Well, let's see. The first step is that I'm going to make this note. Since the pKs are a convergent sequence, we know by problem 70 that the pKs are a bounded set. And what does that mean? That means there exists a capital M that is bigger than 0, such that minus m is less than pk, and pk is less than capital M for all k's inside the set of natural numbers. In other words, we can say that the absolute value of pk is less than capital M for all k's inside the natural numbers. Now, I'm kind of running out of room here, so I'm going to continue in the next panel. Well, yeah, let's continue in the next panel. The next thing I want to do is I want to note that delta divided by capital M is a positive number. And that means that the ball centered at 0 of radius delta over capital M is an open interval that contains 0. And since the qk sequence is known to converge to 0, there is a capital N inside the natural numbers such that if little n is bigger than or equal to capital N, then Qn has to be inside this delta ball. This delta ball has radius delta divided by M. So what does this tell me? This tells me that if little n is bigger than or equal to capital N, then what I know is that Qn is between delta divided by M on the top side and minus delta divided by m on the bottom side. In other words, the absolute value of Qn is going to be less than delta divided by capital M. So now what I want to do is I want to look at this. If little n is bigger than or equal to capital N, then I claim that Pn times Qn will indeed be an element of the delta ball centered at 0 of radius delta, which of course is a subset of my original open interval S. I still have to prove this claim. So now let's start looking at the proof of the claim. Well, let's see. We are going to let little n be bigger than or equal to capital N. So let's see. I'm going to look at the absolute value of Pn times Qn. Now the absolute value of Pn times Qn is just the absolute value of Pn times the absolute value of Qn. That's a property of absolute value. But now I know that the absolute value of Pn is going to be less than capital M. So the absolute value of Pn times the absolute value of Qn is going to be less than capital M times the absolute value of Qn. And this is since the absolute value of Pn is less than capital M because capital M is a bound on the set of pKs. We did that back in the previous panel. But now little n is bigger than capital N, and that means Qn is inside the delta ball centered at 0 of radius delta over M. In other words, I can now say capital M times this absolute value is going to be less than capital M times delta over capital M. And I know this because if little n is bigger than capital N, then Qn belongs to the delta ball centered at 0 of radius delta divided by M. So the absolute value of Qn is less than delta over M. That was the stuff that we just went through. But M times delta over M is, of course, delta. So what I want to do is I want to think about what we've actually just done. What we've done is we have shown that the absolute value of pK, rather the absolute value of Pn times Qn is equal to this, which is less than this, which is less than this, which is equal to delta. So the absolute value of Pn times Qn is strictly less than delta whenever little n is bigger than or equal to capital N. Now I want to think about what that means. So minus delta is less than Pn times Qn is less than delta whenever little n is bigger than or equal to capital N. And that says Pn times Qn is indeed an element of the delta ball centered at 0 of radius delta, which is a subset of the interval S. And that says, and this is true whenever little n is bigger than or equal to capital N. And so that says that the whole entail, the capital entail of my sequence, pk times qk, is trapped inside the open interval S, and that says the sequence converges to 0 by the definition of convergence. And this gives you a good idea of how you take the scratch work and turn it into the formal proof.